Dear students, I am Dr. Kumar Saini, Associate Professor in Mathematics in BLJS College Tosham. In BLJS College Tosham, District Bhiwani, Haryana. Today I will deliver lecture on vector calculus for the students of BA BSc first year semester 2nd. Today I will give lecture on the topic surface integral and its examples. Now surface integral you know this is line integral, this is surface integral. An integral which is to be evaluated over a surface is called a surface integral. जो surface के ऊपर, this is your surface. An integral which is to be evaluated over a surface is called a surface integral. उसको हम surface integral कहते हैं. एक इंटीग्रल जो इवेल्यूएट करते हैं ओवर ए सरफेस, इस सरफेस के ऊपर, इट्स कॉल्ड सरफेस इंटीग्रल. सपोज एस इज द सरफेस ऑफ फाइनाइट एरिया. डिवाइड द रीजन इनटू एन सब एरियाज डेल्टा S1, डेल्टा S2, डेल्टा Sn. इन ईच एरिया डेल्टा S1 choose an arbitrary point pj xj yj zk zj. Now let phi be a scalar point function defined over the area S. Now form the summation sigma I running from 1 to n phi pj delta si where phi pi is equal to phi xi y zi. Let us take the limit of this sum as n approach to infinity. As n approach to infinity, ये सम है और जो नंबर ऑफ डिवीज़न की है उसको इन्फाइनाइट कर दो. As n approach to infinity, each sub एरिया डेल्टा Si reduces to a point पे रिड्यूस हो जाएगा. एंड द लिमिट ऑफ दिस सम इफ इट एग्जिस्ट इज कॉल्ड सरफेस इंटीग्रल ऑफ phi over S over surface S and is denoted by double integral over S phi ds. डबल इंटीग्रल ओवर S phi ds, इस तरह से हम इसको डिनोट करते हैं. ठीक है. नोट है, if S is piecewise smooth, then the function phi x y z is continuous over S. Then the limit exists and is independent of subdivisions and choice of the point P. कहता है if S is piecewise smooth, then the function phi x y z is continuous over S. Then the limit exists and is independent of subdivisions and choice of the point P. If S is piecewise smooth, then the function phi x y z is continuous over S. Then the limit exists and is independent of subdivisions and choice of the point P. नोट दोबारा पढ़ते हैं. If S is piecewise smooth, then the function phi x y z is continuous over S. piecewise smooth हो तो phi x y z क्या है, कंटिन्यूस मिलेगा सरफेस के ऊपर, देन दी लिमिट एग्जिस्ट, और लिमिट एग्जिस्ट करेगी, और वो लिमिट इज इंडिपेंडेंट ऑफ सब डिविजन्स, कितने सब डिवीज़न करते हैं उस पर डिपेंड नहीं करेगी। चॉइस ऑफ पॉइंट पी कहाँ पे, इस पर भी नहीं डिपेंड करेगी। सरफेस इंटीग्रल ऑफ वेक्टर फंक्शन ऑफ और फ्लक्स, suppose S is this is the S surface and this is P point and this we take as delta S. Suppose S is a piecewise smooth surface so that the vector function f defined over S is continuous over S. Suppose S is a piecewise smooth surface so that the vector function f defined over S is continuous over S. Let P be any point of the surface S, and suppose n cap is a unit vector in the direction of outward drawn normal to the surface S as at P. Suppose S is a piecewise smooth surface so that the vector function f defined over S is continuous over S. Let P be any point of the surface S, and suppose n cap is a unit vector in the direction of outward drawn normal to the surface S at P. To each elementary surface ds of the surface S, कहता to each elementary surface ds of surface S be associate a vector ds whose magnitude is ds and direction normal to the surface S. So therefore ds equal to n cap ds. Suppose S is a piecewise smooth surface so that the vector function f defined over S is continuous over S. Let P be any point of the surface S, and suppose n cap is a unit vector in the direction of outward drawn normal to the surface S at P. To each elementary surface ds of surface S be associate a vector ds whose magnitude is ds. To each elementary surface ds of surface S, be associate a vector ds whose magnitude is ds and direction normal to the surface S. Therefore ds equal to n cap into ds. To each elementary surface ds of surface S, be associate a vector ds whose magnitude is ds and direction normal to the surface S. Therefore ds equal to n cap into ds. Then the component of f along n is equal to f dot n, and the integral of f dot n over S is called the surface integral of f over S, and is denoted by double integral as f dot n ds. It is also called flux of f over S. दोबारा करते हैं, let us. To each elementary surface ds of surface S, ये elementary ds ले लिया, S का छोटा ले लिया. Be associate a vector ds वेक्टर ले रहा है, whose magnitude तो ds है लेकिन ds वेक्टर, and direction normal to the surface S, और डायरेक्शन क्या, नॉर्मल टू द सरफेस S. Therefore ds equal to n cap into मैग्नीट्यूड तो इसका ds है और डायरेक्शन n cap की तरफ है, नॉर्मल टू द सरफेस. Thus the component of f along n, f फंक्शन है, उसका कंपोनेंट n वेक्टर की तरफ इज इक्वल टू f डॉट n होगा. and the integral of f dot n over s is called, और अगर इसका f dot n का इंटीग्रल ले लेना, is called the surface integral of f over s, surface integral of f over s, and is denoted by double integral over s f dot n ds. It is also called flux of, और कहता है it is also called flux of f over s. It is also called flux of f over s. Different forms of surface integral. 1. Flux of f over s. Flux of f over s equal to double integral s f dot n ds is equal to double integral s f dot ds. Flux of f over s. Flux. Different forms of surface integral. Flux of f over s equal to double integral s f dot n ds is equal to double integral s f dot ds. Suppose outward drawn and normal n to the surface s at p makes angles alpha, beta, gamma with the positive directions of the axis. Suppose outward drawn unit normal n cap to the surface s at p makes angles alpha, beta with the positive directions of the axis if L and N denote the directions cosines of the outward drawn normal, then L equal to cos alpha, M equal to cos beta, N equal to cos gamma. Therefore n cap equal to cos alpha I plus cos beta j plus cos gamma k. Therefore f equal to f1 I plus f2 j plus f3 k, and f dot n equal to f1 cos alpha plus f2 cos beta plus f3 cos gamma. From 1, flux of f over s, एक से इक्वेशन नंबर 1, फ्लक्स ऑफ f ओवर s डबल इंटीग्रल और s f1 cos अल्फा माइनस प्लस f2 cos बीटा प्लस f3 cos गैमा इंटू ds. ये f डॉट n क्या होता है, f1 cos अल्फा प्लस f2 cos बीटा प्लस f3 cos गैमा इंटू ds. क्या कह रहा है ये, thus ds cos alpha is the projection of area ds in the xy plane, yz plane. Thus ds cos alpha, ये ds cos alpha क्या है, प्रोजेक्शन है ऑफ एरिया ds एरिया का ds cos alpha क्या प्रोजेक्शन है ऑन yz प्लेन पे. Therefore ds cos alpha is equal to dy into dz. ds cos alpha क्या है, dy into dz. Similarly ds cos beta and ds cos gamma on the projections of the area ds on the zx plane and xy plane respectively. So ds cos beta equal to dz dx and ds cos gamma equal to dx dy. From equation number third equation, second, I think he is third. Now from third equation, double integral s f dot n ds is equal to double integral over s f1 dy dz plus f2 dz dx. Putting the value of cos alpha, cos beta, cos gamma, f1 dy dz plus f2 dz dx plus f3 dx dy. This and note है, in order to evaluate surface integral, it is convenient to express them as double integrals. by taking the projection of surface S on one of the coordinate planes. This will happen only if any line perpendicular to coordinate plane chosen meets the surface in one point only. Surface S is divided into subsurfaces if our requirement is not met, so that subsurfaces may satisfy the above requirement. In order to evaluate surface integral, it is convenient to express them as double integrals by taking the projection of surface S on one of the coordinate planes. Thus, this will happen only if any line perpendicular to coordinate plane chosen meets the surface in one point only. one point पे मीट करे, दो पे ना करे. एक surface S is divided into subsurfaces if our requirement is not met, so that subsurfaces may satisfy the above requirement. एक ही जगह काटे. ठीक, अब आगे we will do it. For suppose surface S is such that any line perpendicular in xy plane meets S in not more than one point. Let the equation of surface S be z equal to hxy. This is the figure, z equal to hxy. Let R1 be the orthogonal projection of surface S on xy plane. This is R1. dx dy, ds का dx dy orthogonal projection है in on the xy plane. Then projection of ds on dxy plane equal to ds cosal gamma, and gamma is acute angle which the normal n cap to the surface S makes with positive direction of z axis. Therefore, ds cos gamma equal to dx into dy. ds cos gamma बराबर dx into dy. What? Cos gamma equal to absolute value n cap into k cap. But absolute value of n cap k cap equal to absolute n dot k cap. From 5 ds equal to dx into dy, but absolute value of n cap into k cap. Thus, double integral as f cap dot n cap ds equal to double integral over r I, r1 है क्या, f dot n cap dx dy बटे absolute n cap dot k cap. This is the figure. ds equal to dx into dy n cap k cap. Thus, double integral over s f dot n ds equal to double integral r1 f dot n dx into dy but a magnitude of n cap into k cap. Similarly, we have double integral s f dot n ds equal to double integral over r2 f dot n dy dz n dot I, magnitude of n dot I, and this equal to double integral over r3 r1 f dot n dz dx divided by magnitude of n cap j cap, where r1 r2 r3 are the projection of s on by z plane and zx plane respectively. So this is the theory of surface integral. In the next lecture we will discuss about its questions. Related to this is a question. We will go through this. Okay, now if there is any question or any query, you can ask me at any time, and you will view this lecture on our college website www.bljscollege.com. Thank you students. Thanks.